So last time we focused on our friend volume of prisms, and today we're going to do cylinders. So we're going to derive the formula and practice, practice, practice. Now cylinders, turns out, are much less complicated than prisms because you don't need to discover what base. Oh, what's the area of the base? What's the shape? It's always for cylinders. The base is always a circle, so it's never going to be complicated in that manner. All right, so let's first write the volume of a cylinder. I'm going to start by writing the volume of a prism and then deriving it. The volume of any old prism is area of the base times height. Of course, the base could be a square. The base could be a hexagon. The base could be whatever. So this part changes right here. But the height is the distance between the bases. Doesn't really change in terms of concept. However, since in a cylinder, the base is always a circle, then b is just pi r squared, and h, the distance between the circles, is that. So there's my super secret formula, pi r squared h. All right, so looking at this first diagram, no complexity there. We recognize this here is my radius, and this here is my height. So I'm going to plug it in. Volume equals pi r squared h. It's written for me, I know, but practice makes permanent. 6 squared times your height, which is 5. Remember, height does not have to be vertical. It could be left and right. So this one here will give me exactly 180 pi. So there is one answer, and that's centimeters squared. Now the approximate values, when I plug that into my calculator, 0.5 centimeters squared. All right, so either answer is acceptable depending on the instructions. If it says leaves in terms of pi, like many MCAS might say, then the first one would be my answer. If you have a calculator, then most likely the bottom one is what they're going to look for here. All right, take a moment to practice with number 2. So practicing one more. Again, pi r squared times h. Here's my radius. And here's the height, not because it's up and down, but because it is between the bases. Pi 4 squared times my height 11. The exact answer, 76 pi. And then the estimate would be 552.9. And both of these are inches squared. Let's take a look at number 6. What's the main difference between number 6 and the other ones? All right, so clearly here we know the volume and we are trying to find the radius. So I'm going to still start off with volume is pi r squared times h. This time I know that my h is 10. My r is unknown, so I'll put x in there. And volume, the 1253, I'll put on the left side. So I substitute where I can. Pi r, let me change that to an x though, pi x squared times my height. Now notice there are 2 things to get rid of on the left side, or right side, excuse me. 2 things to get rid of. I'm going to get rid of the 10 and the pi. Get rid of the 10 and the pi by dividing. Pi drops out, 10 drops out. This is going to give me an approximate value when I do finish up here. So with your calculator, you're going to say 1253 divided by 10 pi. When we divide, we get approximately 398.8, 398.8. And now we need to square root both sides here and here. So with your calculator, just hit the square root button, and x is going to be approximately just about 20. Good, so approximately 20, and I forget my units, meters. Now, let's see, does that make sense in the diagram? Okay, good. So I went back to check to see if this was right, and to me, the diagram seemed way wrong, so I wanted to go back and check. And as we discovered, this right here is 39.888, like that, equals x squared. Good, so now we take the square root of both sides to get a more better answer. So my radius is approximately 6.3, which doesn't have to be, but this to somewhat to scale, 6.3 fits much, much better up there.